Please give him a round of applause as he comes to the stage.
Right. It is still morning. Good morning, everyone. We're going to have to shake things up. You've been watching a lot of presentations, and it takes a lot to get in the mind. I think we should bring that group that are waiting outside, bring them in. Come on in. All right, while they're coming in, just to tell you a little bit about myself, my name is Steve, and I run a STEAMI-based program in Cape Town. We teach a few thousand students a week. I also teach online in many countries around the world. I was just recently in the USA at the STEAMI conference, which is the largest EdTech conference in the world, with about 50,000 delegates. And of course, what was the flavor of the month? AI. And I think there was one little thing that a lot of you were missing about AI. AI models like ChatGPT are language generated, but from a data set. So AI is not inventing things from nothing, it's inventing it from the data set that we feed it. So the more accurate the data set, the better the responses from AI, and they'll continue to improve. But I can tell you now that AI is notoriously bad at mathematics, and the prof over here claimed that he got an award according to AI. I don't mean to brag, but I was also given the same award from Cyril Ramaphosa. I should actually put that on my CV and quote ChatGPT. But I can tell you now that AI is going to change a lot of things. And if there are any teachers here who are interested, I have a lovely document with loads and loads of AI resources for you that you can use from a teaching point of view, and also to check to see if the work that is being submitted from the students is actually done by themselves or if it has been AI generated. All right, are we ready to start? Yes. Okay, let's get your minds working in a mathematical way. When I point to this side of the room, I want to hear one single clap. When I point to this side of the room, I want to hear one single clap. All right, are you ready? That was lousy, about 12 or 15 claps. Oh, what's going on in the Free State, man? I mean, if you're in Cape Town, I mean, slapstuck, but Free State, whoa, whoa. Are you ready? Now we're talking. We're getting better. Sis, I was pointing over there, and you're... Yo. This group over here, you wouldn't fall for that trick, would you? Would you fall for a trick like that? No. All right, are you ready? 1, 2, 3. You looked me in the eyes and said no, and then, yo. All right, come on, people. You need to be awake here. Are you ready? Thank you. Now, why did I do that? Actually, there was method in my madness. Mathematics at school, in some schools, not all schools, is taught in a certain way where students like to learn a pattern. And as soon as they go and write a test or an exam, they go, hold on, we haven't learned this in class. And the teacher goes, we did it yesterday. But that's not how you taught us in class. And the teacher goes, it's the same sort of thing. So what you need to learn is that with a mathematical mind, you have to be able to adapt and change, rethink certain problems. And it's all about problem solving. And I can tell you now that the little exercise, once I caught you out the first time, I didn't catch you out the second time. And that means you were sitting there going, okay, I'm ready for you, bring it on. And that's the attitude that you need in a maths class. Now, some of the things I've got to demonstrate, I think might be a little bit difficult for everyone to see, but we're going to give it a go anyway. I have got a mind-reading exercise to do on the screen. I need someone who is brave enough to put up their hand and choose a number from 1 to 63 without telling me the number. Is there someone who's brave enough? Oh, I'm so glad you volunteered. You should see the way they were volunteering like this. What's your name? Math. Okay, choose a number from 1 to 63, but do not tell me what the number is. Okay, have you got a number? What's your number? You're not supposed to tell me what it is. We're going to do it again. Choose another number, but don't tell me what it is. Have you got a number? What's your number? Oh, she's not telling. Can you see your number on slide A? Yes or no? Yes. You can. Can you see it on B? Yes. You can. Can you see it on C? Yes. Can you see it on D? No. Can you see it on E? Yes. And can you see it on F? No. She chose 23. Did you choose 23? Yo. You know what? Maybe I got lucky. There were 63 numbers, and I picked one of them, and I just happened to pick her number. So what are the mathematical odds I'm going to choose someone's number again? I need another volunteer. Someone who's feeling brave. There we go. What's your name? Sorry? Amanda. It's a lovely name. I was going to call myself that when I was a little girl. All right, Amanda, I want you to choose a number. Have you got one in your head? Don't tell me your number. Can you see your number? Do they have a screen here for you? Oh, but you can see this one. Is it on slide A, yes or no? It is. Is it on slide B? No. Is it on slide C? No. How about D? It is. What about E? And F? Which number was it? It starts with a 4 and ends in a 1. Was it 41? Yo. That's 2 out of 2. 2 out of 2. Now, when people see this, they go, that is incredible. He was reading their minds. He has this incredible ability just to climb inside their heads and know what's going on. But when I tell you how it's done, you're going to shake your head and go, but that is really, really easy. And a lot of mathematics is like that. When you are learning certain things about mathematics in school, it looks very complicated, very fancy, but once you learn the mechanics behind it, it's actually a lot easier than you think. So here's the deal I'm going to make to you. If you have got access to email, you can go on to livingmaths.com and send an email to info@livingmaths.com. That's me, info@livingmaths.com, and I'll send this thing to you. You can then go and drive your friends and family absolutely crazy with reading their mind. So how does it work? I want you to take a look at the top left-hand corner number. What do you notice? The number? 1. If you said 15, it's your other left. It's the one on this side, okay? 1. What do you notice next? 2. Can anyone predict what is going to come next? 3. No. It is actually 4. So hold on. We've got 1, we've got 2, we've got 4. Can anyone guess what's going to come next? 8. Why do you say 8? Because there's no wrong answers. Why do you think it's 8? Well, is there a pattern? What is the pattern? Doubling. Let's see if you were right. Look at that. So then if that is the case, what's going to come next? 16 and then 32. Now, of course, these are what we call binary numbers. I'll go into that a little bit later, but the way this trick works is there are 2 ways of explaining it. I can explain it in the complicated way, and I can explain it in the simple way. The complicated way, which I don't expect you all to understand, is that if I gave you 6 bank bags, and I gave you 63 1 Rand coins, and I said, put those coins into those 6 bags, and when you've done that, you have to seal each bag. And then I can ask you for any number from 1 to 63, and you have to give me the exact number of coins without taking any coins out of the bag or putting any coins in. And you're going to go, well, how do we arrange the coins? I'll get to that answer, but let me first give you the simple explanation, and I'll show you how the two tie together. So what I do is I pretend I have this imaginary empty glass, and it's sitting on my head. I ask you to pick a number. Let's pretend you choose the number 13. I ask you, is your number on slide A? Is 13 there? Yes. Then I take 1 sweet, and I pop it into my cup. I then go on to the next slide and I say, is your number there? You say, no. Then I ignore the number 2. I then go along to slide C. Is your number there? Then I add 4 more sweets into my cup. How many do I have so far? 5. Is your number here? I add 8 more into my cup. How many do we have so far? 13. Is your number here? The answer is no. Is your number here? The answer is no. So if there were 13 sweets in the cup, the number that you chose must have been 13. Do you understand that? Well, don't get excited, because now we're going to put you to the test. I'm going to choose a number, and you're going to have to work out my number. All right, I have got one. Is it over here? Yes, it is. So some of you are already taking your cups and putting 1 sweet in. Is it over here? Yes, it is. No, it is not on C. Is it on D? Yes, it is. I see a lot of calculations going on. Is it on E? Yes, it is. Is it on F? No, it is not. Can anyone tell me? Shout out, what is my number? Outstanding. Normally when I do this, you get 27. Then one person goes, 25! And realize they're the only one who didn't actually add it up correctly. But if you did add it up correctly, it would have been 27. So now if you really want to take this one step further, you can go and do what I've done. I've got them over here. You print out these sheets. You can do it obviously on a 1 piece of paper. You don't have to print them like this size. This is only when Eskom is not behaving. And then what you do is you ask someone to pick a number from 1 to 63, look through the sheets, and just call out the letters of the sheets that it appears. So they'll go, oh, it's on A, B, and C. Now in my head, I know A is, B is, and C is. What is 1 plus 2 plus 4? So without even looking at the sheets, I go, hold on. If it was A, B, and C, did you choose the number 7? And that freaks them out. They have no idea how I could have known their number if they only gave me the letters, but they don't realize that by giving me the letters, they've actually told me exactly which numbers they've chosen. And how does it connect to the hard way of explaining it? Well, interestingly enough, if you put 1 coin in the first bag, 2 coins in the second, 4 in the third, 8, then 16, then 32, you can make any number from 1 to 63. Who's going to go and try that trick at home? I hope so. Remember, you can always email me and I'll send it to you. All right, I thought I'd try something a little bit different. This is a different type of mathematics. You see, maths is not always about sums and numbers. Sometimes maths is also about observation. Now, people in the cheap seats at the back, I hope you can see this. I have got 3 cups. 3 cups, and I'm taking, I believe I have a coin in here. Maybe I put it in the other pocket. Whoop! Here we go. I have a coin. Can you hear it? And I'm going to test to see if you're able to work out where it is. So we'll start off. Nothing. Nothing. All right, ready? Right. You'll never guess this one. Is it this one over here? No. This one? No. This one? Yes. Okay, hold on. I was going too slow. I need to go faster. All right, are you ready? Ha! Now you are not going to get it. Is it this one here? No. Is it this one here? Yes. Who thinks this one? No. No, this one? Yes. I know what the problem is. This coin is making a noise and you could hear it. I need something a little bit quieter. Oh, thank goodness. Amanzi. How about we put some of this in one of the cups? I'll just put a little bit. Is that enough? Yes. Maybe a bit more. No. Teeny bit more. No. Okay, just a little bit more. Now, this is going to get interesting. Because, I used almost half a bottle of water here. Can we hear the water? No, we can't. Can we hear anything? No, we can't. Let's see how good you are now. What's it over there? Oh, ho, 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 ho. Is it in this one here? No. Are you sure? Yes. You're very sure? Yes. Ah! You told me it wasn't there and you were sure, and when I did this, you went, ah! Is it in this one? No. You don't seem so sure now. It might be, it might not be. Are you ready? No, I wouldn't throw it. Ah! Oh, look at that. You ducked as well. Which means there's one cup left. Is it this one? Yes. Do you guys have cloths to dry up the stage? Nope, wasn't that one either. Sure. Where did the water go? Oh, maybe there's a hole in the cup. And I want to hear some theories. Who thinks it evaporated? Because it's quite warm today. Maybe it just evaporated. Where did the water go? I want to hear some theories. Oh, I could see. Okay, I'm giving you 10 seconds. Talk to the person next to you. I want to know, where did the water go? Go, 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 go. Woo! Oh, I've got some theories. I see it. Amanda knows. Amanda knows. What is it, Amanda? Amanda knows. She said that it probably has a hole at the bottom and it was all pouring into the tablecloth, and you are absolutely not right. It's not a hole. I'm coming to this side. I saw a hand over here. What do you think? What do you think? Okay, so someone over here might have seen this before, knows, but actually, in some of the sessions that I do, students will tell me, oh, it's because there's a sponge in there. If I had poured that much water into a sponge, let me tell you, that would be pouring all over my head. The answer is a very, very impressive invention. I don't think any of you have ever seen one of these before. I have brought one here to South Africa to show you. I do have one. Here we go. It's called a nappy. Have you seen one of these before? Yes. Oh, you have? Oh, that is not so impressive. But of course, a nappy, as you know, when you tear the top layer, inside it looks like cotton wool, but this is actually not cotton wool. It's a super absorbent polymer that actually it absorbs all the liquid and turns it into a gel. And of course, you don't only find these in nappies, you find these in feminine hygiene products, and it's a good thing that it's super absorbent, because of course what it does is it keeps baby dry for the whole day, which I think is a wonderful thing. All right, did you like that trick? You can try that on your friends, but don't use a see-through cup. Unfortunately, that gives it away. Well, you know, when I was your age, we were very poor. And I asked my parents, please, can I get a hamster? And they said to me, no. I asked them, why not? They said, hamsters cost money. You have to feed it. You've got to take it to the vet. It's got to have its hair and its nails done. And let me tell you, don't you take your hamsters to have their hair and nails? Well, that was the story I was told, and I was told you cannot get a hamster because of that. So I had to make my own pet. And isn't he sweet? Look at this. I call him Pasty. Can you see Pasty? I'll come round and show you. What? Do you know what he is? What do you think he is? Toothpaste. He's very cute. That's why I call him Pasty. And this is Pasty over here. It's a tube of toothpaste. And Pasty and I have been working on some tricks together. Here we go. Can you all see that? He's very cute. You want to touch? Touch. He doesn't bite. There we go. Oh, no, I'm joking. He doesn't bite. He's very friendly, very friendly. And for the last few weeks, we've been working on some tricks. So, for example, Pasty, stay. Look at that. You don't seem very impressed. It took a long time to get him to do that. How about this one? Pasty, can you swim in a circle? Look at that. You also don't seem very impressed. Okay, our latest trick I think will impress you. Pasty, can you please swim down? Stay. And go back up again. Isn't that clever? What is going on? Have a look. Pasty, come down, but only halfway. A little bit more, Pasty. Stop. Go down. Stop. Go back up again. Unbelievable. Pasty is so smart. Let's give Pasty a round of applause. But now the question is, how did Pasty do that? Oh, I see a hand up over there in the middle. Yes. Why? There's suction if you squeeze the bottle, but hold on, if I squeeze it on top, will the same thing happen? You see, mathematics and science involve a little bit of curiosity. You have to experiment and try different things. So there was a theory that if I squeeze, it causes suction. But actually, there's a wonderful exercise called the Cartesian diver. And inside this tube, there is some toothpaste and a nice air bubble. You do not have to use toothpaste. You can actually take a little ketchup from the takeaway place. You drop it in a glass of water. If it floats on top, no good. If it sinks to the bottom, no good. But if it floats like this, it means there is an air bubble inside it, and it's balancing with the tomato sauce, so it's what we call buoyant. And as soon as you put it inside a bottle like this, you fill it to the top with water. When I squeeze this bottle, it puts pressure on all the water. Where does the water go? It has nowhere to go. So it starts putting pressure on that air bubble in the toothpaste tube. And when it squeezes that air bubble, you have a change in density and it sinks to the bottom. But the minute I stop squeezing, all of a sudden that air bubble just inflates itself and it goes all the way back up. So you can actually go and make your own pasty or your own ketchi. It's all up to you. But I thought I would end off with one last trick. And you see, one thing people say to me is, why do you show people how to do it? Because, you know, when it comes to learning, I always like to inspire students by asking a question and getting them to discuss it. And then sometimes I show them an experiment and ask them what they think. When students become emotionally engaged, they listen. And that's when you can teach them a lot of cool things. So, how many of you have ever seen a movie called Matilda? Some of you might have even seen the play. And what could Matilda do? She could move things with her mind. I'm going to try to move the bottle. Is it moving? Is it moving? Did you see it fell over? Now I know what you're thinking. I know what you're thinking. Oh, he was pulling the towel. My hands are here. Watch my fingers. Whoop! How is that possible that a bottle could move? And I know what you're thinking. I know how he does it. There is something underneath the table. What I'm going to do is show you this. Do you know how that works? When you blow, it lifts up. Isn't that amazing? You just have to blow really hard, and then it lifts. Sometimes it. Whoa. So how was that done? Come on, scientists, any ideas? Would you like to see the answer? Who wants to see the answer? Put up your hand. Okay, I confess. It is a spoon. And as you know, a spoon is a wonderful tool. When you place it on the table and you push down the one end, the other end comes up. So you go and stick this under the tablecloth and you start making cups and things move under the table, you are going to freak your family out. And of course, if you take the spoon and place it behind the towel like this, you could start pushing it and it actually looks like the towel is taking off. Now, from what I can understand, I believe my time is up. Is that correct? Or are they giving me more? Are we getting more? Can we do one more thing? All right. Yeah, I love it. I want to give away a prize. I have over here in my pocket my annual salary before tax. It's 100 Rand. And what I'd like to do is offer this as a potential prize to someone in the audience. If they don't win the challenge, I will still give them a prize anyway. Are there any takers? Any takers? Let's choose someone right at the back. Are you a teacher? Are you a student? Then come on up. We've got to give a student a chance. Come on up. Don't be shy. All right. What is your name? Sibusihle. Sibusihle. See, but I don't speak Sotho. What do you speak over here? Sotho. Okay, I don't speak Sotho. All right, but it's quite similar to Xhosa, isn't it? Okay, no. All right, so here's what I want to say. I have 100 Rand. All you need to do is fold it in half 10 times. And I don't mean like this. 1, 2, 3. I mean 1, 2. You could also actually do it this way, because that is still a half. If you can do it 10 times, the money is yours. If you can't, the money is mine, but I will still give you a prize. There we go. And off she goes. She's on number 1. Oh, she's thinking about it carefully. Number 2. Oh, this is serious money here. Serious money. Whew. How are we doing at the moment? How many is that? 5. She's halfway there. My money's almost gone. And now? How many is that? 6. And then? Oh, no. Let's have a look. Let's have a look. I'm going to just test it. Okay, you're watching. You hold it. You hold it. I'm going to use this one over here. Now, are you ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Didn't happen. Hey. You know what? I feel bad. So we're still going to give her a prize. Who thinks they could do it? You know, a lot of hands are going up now. Well, I've got some sad news. It can't be done. And I'm going to tell you why, mathematically speaking, but I think I have a prize for you in one of my pockets. Here we go. There we go. Give her a round of applause. So how does it work? Quite simply, there are 2 mathematical reasons why it can't be folded 10 times. Number 1, when I fold it in half, it's gone from 1 sheet to 2. When I fold it again, it's gone from 2 sheets to 4. Has anyone seen this pattern anywhere else today? What's going to come next? 8, then 16, then 32, 64, 128, 256, 512, 1024. And if you could do it 10 times, your paper is going to be 1,024 pages thick. That's 2 packets of photocopy paper on top of each other. The other problem is that it gets smaller. How do you say small in Sotho? Andazi. What? That's what I was going to say. So if you take it and you fold it the first time, now it's half the size. You fold it again, it's half of a half, which is a quarter. If you fold it in half again, what's half of a quarter? An eighth. And if you fold that in half, it's going to be a 16th. And then a 32nd. And if you could fold in half 10 times, it's going to be 1,024 times smaller. So if it's going to be shrinking that size and getting that thick, there's no ways you can do it. So to end off, here's what you're going to do. You go home today, you say to your mom, could I please borrow 50 rand? And she goes, what do you need 50 rand for? You say, I'll give it back to you in 5 minutes. You go to your dad and say, Dad, would you like to win 50 rand? Your dad says, I would love to win 50 rand. What do I need to do? You say, if you can fold this in half 10 times, you can have 50 rand. And he says, if I can't, then you give me 50 rand. How much money are you making from your dad? 50 bucks. Then you go back to your mom and you say, Mom, here's your 50 rand. Would you like to win my 50 rand? Mom will say, absolutely. And what do I need to do? If you can fold this in half 10 times, I will give you my 50 rand. And if I can't, then you give me your 50 rand. How much money are you making tonight? Isn't it amazing how good your maths gets when it comes to winning prizes? Well, I'm afraid we've run out of time, but if you do want to come and chat to me, I will be sticking around here, and I would love to get to meet you. We do a lot of exciting things. If you go onto livingmaths.com, you can see we do a lot of online interviews where we interview astronauts and scientists, and you are welcome to join in on the Zoom calls, and you get to ask the questions too. And just 3 months ago, we had an astronaut out in South Africa, and maybe we're going to chat to Sasol and see if we can bring an astronaut out to this side of the world as well. So thank you very, very much.